All right, y'all. So 7.1 is going to deal with our symmetry. All right, so there's three types of symmetry we're going to look at in this section right here. So the first type of symmetry is what we call symmetric to the y-axis. And remember, symmetry is like your human body. If you cut it right down the center, your left side would be symmetric to the right side. So that's sort of what we're looking at. So if it's symmetric to the y-axis, then if you fold the graph along the y-axis and you fold it over, if the graph lands on top of itself, then it's symmetric to the y-axis. So folding along the y-axis and the graph, well, how about this? And the right side of the graph lands on the left side of the graph. Also, if a graph is symmetric to the y-axis, we say that they are what we call even functions. So graphs that are symmetric to the y-axis are even functions. Okay. Now that's because the graphs that are going to be symmetric to the y-axis have even exponents. Okay. So they have even exponents. Okay. And technically, in the graph crosses the x-axis an even number of times. So even function are going to be the ones that are symmetric to the y-axis. And that's because the even exponents make those U-shaped parabolas, and they also cross the x-axis an even number of times. So an example of something like that would be those parabolas that we've been drawing. So this parabola, if I was to take this and fold it over the y-axis, this right side would land on top of this left side. Also notice it crosses it once, twice. It crosses it an even number of times, okay? And then this would be the x squared graph. So x squareds, x fours, x sixes, anything with an even exponent is going to sort of make that parabola shape, okay? All right, so we got symmetric to the y-axis. We got symmetric to the x-axis. So the same thing, except now we're going to fold it along the x-axis. So folding along the x-axis, and the top side of the graph lands on the bottom side of the graph. Okay, so the top is going to fold over and land on top of the bottom. So an example of that um, would be something like this, where if I folded it over, this top part would land exactly on that bottom part right there. Okay. Now, if it's symmetric to the x-axis, it's not an even function or an odd function because remember, this thing fails the vertical line test. So if it's symmetric to the x-axis, it's not even a function technically, okay? But the third one I'm about to do will be the odd. See, I got my even here. So the third one will be symmetric to the origin. So remember, the origin is the center of the graph here. So if it's symmetric to the origin, rotating the graph 180 degrees. Now, basically, when you're rotating the graph 180 degrees, you're turning it upside down. But rotating the graph 180 degrees, and we have the same graph. So if I rotate it 180 degrees and my graph looks exactly like it looked when I started, then it's symmetric to the origin. Now, graphs that are symmetric to the origin are odd functions. Okay. That means they'll have odd exponents and cross the x-axis an odd number of times. Okay, so they're going to cross an odd number of times. So let me show you a picture of a odd function that is symmetric to the origin. Here's the origin in the center. So this graph sort of makes what we would call a sine wave looking graph, okay? But look how this graph looks. Here's the top, here's the bottom. So it comes down, goes uphill, and goes back down. Watch what happens when I rotate this 180 degrees. Well, here was the bottom of the graph, but look, it still comes down, goes uphill, and then goes downhill. The picture looks the same that way as it did the original way. So when you can rotate it 180 degrees and you got the same picture, it's symmetric to the origin, okay? So that'd be like them cube graphs or x to the fifth, x to the seventh. Anything odd like that is going to give us the symmetric to the origin, okay? So y'all to do these, I'm going to pull up MathLab and let y'all guess and see what y'all think these are, okay? So there's only 5 of these questions in 7.1, and you're just looking at the picture and trying to determine what they're symmetric to, okay? So let me pull up 7.1. All right, y'all, so I'm going to make this graph bigger. So y'all, what do y'all think this first one I got drawn? Is it symmetric to the x-axis, origin, y-axis, or no symmetry? Oh, and Claire, you hit that pretty quick, and Jason, good job. It's definitely the origin. Because if you look how this graph looks, it's coming downhill, uphill, downhill. If you turn that 180 degrees, then you'll have the same picture. So good job, y'all. That is definitely to the origin. All right, so you got to check your answer and do the next question. So let me make this one larger. All right, so let's see. X-axis, origin, both the X and the Y, or the Y only. All right, good job, Jesselyn. That's definitely the y-axis. Because if I fold the graph along that y-axis and fold it over, the right side of my graph will land right on top of the left side of my graph. So that is definitely the y-axis. Okay, it's not the x, because if I fold it over to x, the top of this graph will not land on anything but empty space. And it's not the origin because if you turn it upside down, it won't be U-shaped. It'll be sort of N-shaped, I guess you would say, okay? All right, y'all, so let's see. Now, this one's going through them one by one. So the first question they want to know, is this graph symmetric to the x-axis? Yes or no? So yes on that one. Okay, y'all. So you would put yes, and then you're going to check that one. Is it symmetric to the y-axis? All right, good, yeah, because if you fold it over the y-axis, that right side is going to land on nothing there. So that is definitely a no. All righty. Is it symmetric to the origin? Good job. That is definitely a no. See, it's sort of pointing right, but if you rotate it 180 degrees, it would be pointing left instead of pointing right. So it wouldn't be the same picture. So y'all, that one is only symmetric to the x-axis, okay? All right, so let's see what you remember about even and odd. Remember, if it's symmetric to the y-axis, it's even. Symmetric to the origin, it's odd. So knowing that, is this one symmetric to the is it even, odd, or neither? All right, also good job. Since it's symmetric to the y, it's even. And y'all, if you count, it's touching the x-axis 2 times. So that's another way to tell that this one is definitely an even function. All right, y'all, so let's see what this last one has. All right, even or odd. So let me make that a little bigger for you. So yeah, it's going to be odd. And watch this. If you count 1, 2, 3, 4, 5, 6, 7, 8, 9, it touches 9 times, which is odd. And if you took this picture and turned it 180 degrees, you would have the exact same graph. So y'all, that one is definitely an odd. All right, y'all. So that was 7.1. So now we'll get into 7.2. So let me share something real quick in MathLab with y'all. Well, not in MathLab, but in Blackboard. I'm going to go into Blackboard and to help you in this section, if you come down here to your week 2 folder for June 2nd through June 8th and open it, so you got your testing stuff, but you got what's called basic graphs. If you click on this basic graphs, and we'll draw these in a second, but this gives you a picture of the 7 basic graphs that we're going to be moving around in this section, okay? And we'll draw all these real quick, but I wanted y'all to realize that these basic graphs are in the week 2 folder, okay? All righty, so let me get back to my pages. All righty, so for 7.2, we're going to be dealing with transformations. So that means moving graphs around. We're going to move them up, down, we'll move them left and right, and we'll even reflect them over the x-axis. So y'all, for this section 7.2, transformations. Okay, so first, let's draw our basic graphs. So like I said, there's going to be 7 of them. So the first one, looks like a straight line coming through the center. So this uphill straight line is the graph of y equals x. It's the most basic line graph you can draw, okay? All right, y'all, next. We've been drawing these graphs, or we've been sort of playing with them a little bit. The U-shaped parabola, that is the y equals x squared graph. All right, the next one will be a cube, and the cubes were the ones that we drew that sort of came through the center and then went uphill. So this is the y equals x cubed graph. All right, y'all, a few more to go. All right, a V-shaped graph. This was our absolute value, so this would be the y equals absolute value of x. All right, so we definitely played with all of these in 2-1 and 2-2. Now, some that we didn't draw yet, but we're going to know what the shapes are. This one, it sort of goes slowly uphill to the right. This is y equals the square root of x. So the square root graph sort of slowly goes uphill. Now the square root graph ain't on the negative x's. Because remember, in the real world, you cannot take square roots of negative numbers. So that's why the square root graph is only on the positive side, okay? All right, we got one similar to that, not quite as tall, but this one does go to the left side. Okay, so this one slowly goes up to the right and slowly to the left. This is the y equals cube root of x. So you can take a cube root of a negative number, okay? But you can't take a square root of an even number. I mean, an odd number. I mean, a negative number. So I can't take square roots of negative numbers, but I can take a cube root of a negative number, okay? Because a negative times a negative times a negative will give you a negative. All righty, so let me see. That's what, 6. So we got one more to go. Now, this one, they usually don't make us graph this one or not. Um, but this one, part of the graph on the right side does this shape, and on the left side, it's down here doing that shape. This is the reciprocal graph, y equals 1 over x. Now, we will deal with these kind of graphs a lot more at the end of our third testing material, okay? But you don't have to know how to draw these right now. All we got to do is know how to move them around, and we have to know that these are the basic positions of these graphs for the x squared, x cubes, and so forth, okay? They all are touching the origin pretty much, okay? So what we're going to do, y'all, is take these graphs and move them up and down, left and right, and even reflect them. So to help us do that, let's learn how to do these moves. All right, y'all, so these are the transformations. The first thing we'll do to graphs is so yeah, Justin, I seen that chat now. So you can take the cube root of a negative number. So like the cube root of -8 would be -2 because -2 times -2 is 4. And then 4 times -2 would give you -8. Okay, so you can actually multiply them back and get those answers. All right, y'all, transformations. The first one is a vertical. Vertical means up and down, okay? So it'll be y equals f of x plus or minus b. So f of x would be the function like the x graph, the x squared graph, the x cubed, or whatever. So what we're doing is we're adding a number or subtracting a number from the end of the function. So if b is positive, so if I add a number to the end of my function, then this graph goes up. If the b is negative, so if I subtract a number from my function, then this graph is going to go down. Okay? So an example, if I got f of x equals x squared plus 3. This is the x squared function. If I add 3 to it, then the x squared graph will move up 3 units. Okay, now let's do another one. What if my function was x cubed minus 4? So here's my x cubed function. So if I subtract 4 from that, then that means my x cubed graph goes down 3 units. Okay, so we got to know what our basic graphs are, the x squareds or the x cubes, and then what's the adding and subtracting doing to that? Moving me up or moving me down. So that is how you would move these graphs vertical, okay? Next, horizontal. So horizontal is going left or right. So to go left or right, we will have something like this. Y equals f of x plus or minus a. Look at the difference up here. Up here, I didn't do nothing to the x. I just added or subtracted at the end of my function. On horizontal, you're actually adding or subtracting from the x value of the function. So this is usually going to be done inside parentheses, okay? Now, if the a is positive, so if I add to my x before I do my function, then adding will move me left. So these are sort of backwards what you would think. If you add to it, it's going to move it left. If you subtract from the x, it's going to move it right. So that means if a is negative, then you're going to move it right. Okay? So let me give you some examples of these. So if I had f of x equals, so let me play with the square again. But this time I'm going to do x plus 3 squared. Notice the difference. I'm changing the x value before I square it. Here, I squared it first and then added to it, okay? So that's the differences on the verticals and the horizontals. So what's happening right here is the x squared graph goes, since it's being added, remember I said it goes left. So this graph goes left 3 units. Okay. So another example, let's make this minus. What if I had x minus 5 cubed? Right, so the same thing. This will take the cube graph right 5 units since it's being subtracted. Then y'all want to do another example on this one to show y'all one of these with the square roots. If I had something like this, square root x plus 2, square root radicals, we treat it like these things are inside parentheses, okay? So since it's treating it like it's inside parentheses, it would be like this. If it's under the radical with the variable, it's going to move you left or right, okay? So this one would be what? Square root of x graph. Since it's added, we'll go left 2 units. Okay? So if it's under the square root, it'll go left or right. If it's outside the square root, so I didn't do a square root up here, but let's say I did. If I had this square root of x, say plus 2, since the 2 is not under the square root, this one would move the square root graph up 2 units, okay? So the square root of x graph goes up 2 units. So outside the square root bracket or the radical, up or down, inside the radical, left or right. All right, y'all, we got one more move to look at. And this one is a reflection over the x-axis. So that'll be y equals negative f of x. So if I threw a negative in front of my function, then it's going to reflect it over the x-axis. So let's do an example of that. What if I had f of x equals negative x squared. So when we did the negative x squareds the other day, instead of having a U-shaped, when it was negative in front of the x squared, it flipped it over and made it like a peak instead of a valley. So what this is going to do, this is going to reflect the x squared graph over the x-axis. So it don't matter what your function is. If you throw that negative in front of it, it's flipping it over, okay? All right, so let me show you how you're going to graph these in MathLab because they're sort of tricky moving them around a little bit. But once we go through these, you are going to see that they're not that bad actually, okay? So let me go to the 7-2 homework. All right, y'all, so hang on. It's going to make me log back in real quick. All right, so we're on 7-2. All right, so 7-2's pulled up. So let's go to number 1. All right, so the first thing, they want to describe how it can be obtained by one of my basic graphs. Then we're going to graph it. So notice this one. Y equals x minus 3 squared. So since we got a exponent of a 2 on this one, we know it's going to be the x squared graph. Okay? So we just got to know that minus 3 inside the parentheses. Am I going to go 3 units up, 3 units right, 3 units down, or 3 units left? So y'all, that's inside the parentheses. So if it's inside the parentheses, we're going left or right, remember, because you're attacking the x inside those parentheses. All right, so y'all watch out because it won't be down unless it's outside at the end of it, okay? So I'm subtracting, and when you subtract from the x, it's going to move it to the right. Okay, so remember, if the A is negative, you're going to go right. So I'm going to pick the one that says goes 3 units right. So that'll be B. And it's going to say, start with the graph of, well, y'all, that's going to be x squared. So do your x and then do your exponent on it, okay? So your x squared graph, 3 units to the right, you're going to check that answer. Then it wants us to graph it. So you're going to click to enlarge graph. Now, that's why we give you the picture of the basic graphs so you'll know which one of these tools to use. So the x squared graph is going to be the U-shaped tool. So you're going to click that, and then you click anywhere on this graph. It don't matter where you click. It always puts the graph in the middle. Now, we said we're going to move 3 units to the right. So that's a horizontal move. So you come down here where the horizontal button is, and you move it to the right 3 units. Once I move it right 3 units on this panel, it actually moved the graph over 3 units, okay? So once you've moved your graph, you're going to save that. And then you'll what? Check your answer. All right, let me see what's my chat saying. Redo that. So y'all let me go back to 1. All righty, so it gave us a similar problem. All it changed was the number. So I'm subtracting 8 from the x inside the parentheses. So what way will that graph move? Left, right, up, or down? Well, we said if it was inside the parentheses and it was negative, that's going to move me to the right. So I'm going to pick A that says shifted 8 units to the right. And I got an exponent of 2, so that's still going to be my x squared graph. So x exponent 2. All right, so you have to check that answer. Then I'm going to click the enlarge graph. So remember, exponent of 2 was the x squared graph, and we drew that basic graph as a U-shaped. So click the U-shaped parabola for the x squared tool. And then y'all, you can click anywhere on the graph. Anywhere. You click anywhere, it's going to still start it in the middle. All right, so that went 8 units to the right. So here, you're not going to use the top two things. The one that says vertical stretch and shrink, we're not using that at all. We're not using the one that says horizontal stretch and shrink. All we're using is the vertical shift, the horizontal shift, and the reflect over the x-axis. We're not even going to use the reflect over the y-axis in this section. All we're reflecting is the x. So since you're going left to right on this one, that's horizontal. And we said subtracting 8 would actually move me right 8 units. So I'm going to move this cursor over to an 8. Once I moved it over 8 on the box here, it actually moved the graph from the center and it went right 8 units. At that point, you're going to save and then check your answer. All right, let's see what this one has. This one has x minus 7. So this is the x graph. So it's the only one where you actually had to plot points. So subtracting 7 from the x graph, it's not in parentheses. So since you're just subtracting 7 at the end, it's going to move this one down 7 units. So let's see, that would be A. A said shift it down 7 units. And this was the basic line graph of a X. Okay. All right. So you would check that answer. Now this one, on the graph one, you're going to click the 2-point line tool. And y'all, this one, you actually got to plot 2 points. So let's think. If I let x equal 0, 0 minus 7 would give me a negative 7. So my first point would be 0, negative 7. And then if I let my x equal 1, 1 minus 7 gives me a negative 6. So my second point would be 1, negative 6. So just come up with 2 points and plot them. But y'all look, the line graph used to go right through the center. Now it moved it down 7 units, okay? So on your second one, you physically got to graph that line, okay? Save that, and then check your answer. All right, this is the 1 over x graph. They're subtracting 5 at the end of the function. So since the negative 5 is at the end of the function, it's going to go up or down. So since that's negative 5, it's going to go down 5. So y'all, the one that says it goes down 5 is A. So you click on that. Now, when you check that, which of these 4 pictures looks like it went down? A, B, or C? And y'all, I'll tell you the truth. B looks like the basic graph. So it's either going to be A or C. Which one went down? And y'all, yeah, it looks like A did, right? That graph went down and it looks like C went up. So we just click A on that one and then final check, okay? So that's basically what y'all are doing on these. See, notice this one. It's a negative, and then x minus 9 inside parentheses cubed. So we know this is the x cubed graph because that exponent of 3. So since the 9 is negative inside the parentheses, when you're in the parentheses and negative, it's going to move you right. And then that negative in the very front of the parentheses is going to reflect me over the x-axis. So see, two of these say y-axis, so throw them away. It's either going to be A or C with the x-axis. So we said that subtracting 9 would move me right. So let's see. A went left, so it's got to be C, right? C. Because C said shift it right 9 units, reflected across the x-axis. Now inside the box, since that's the cube, this will be the x cube graph, okay? So the negative 9 went right 9, and then the negative in the very front reflected me over the x-axis. So check that. Then I'm going to click the enlarge graph. So the cube graph was the squiggly one that went uphill. So that's the second one on the second row, x cubed tool. Click that and then click anywhere on your graph here. No matter where you click, it's going to start it in the middle. All right, so the first thing, that negative 9, we said move me right 9. So horizontal, I'm going to move that right to 9. Then the negative in the front, we said reflected it. So come down here, and in the bottom left, it says vertical flip when you put your cursor there. So click that. Now watch. The graph was going uphill, but when you reflect it over the X, it looks like it's going downhill now, okay? All right, y'all, so those two moves, you save that, and then check your answer. So this one has two. You got a number inside the parentheses, and then you got a number at the end being added. So this one says, start with the graph of f of x. Well, I see an exponent of 2, so that's going to be the x squared graph. So you're going to put x squared there. Then it says shift it blank 2 units. So down, left, right, or up. So y'all, that 2 is being added inside those parentheses. So what would I move? Down, left, right, or up? And let's see, that 2 is positive inside the parentheses. So that's like a positive A. And we said if the A was positive inside the parentheses, that's going to move me left. So that's going to move me left 2 units. Now, shift it blank 4 units. The 4 is added at the end of the function. So since the 4 is not in parentheses and it's added at the end, that is going to move you up. Oh, you had up there, right? So up 4 units. So y'all, let me make this easier for y'all real quick. Let me do something real quick. Okay, so we got these functions. So you'll have x plus or minus a plus or minus b. This is left, positive, right, negative. This one is up, positive, down, negative, okay? And then, like I said, if you got a negative in the front, a negative in front of your f of x, that reflects over x-axis. So use this guide. Are you in parentheses? You're going left or right. Are you added at the end? You're going up or down. And if you're negative in front of that f of x, and you're negative, that's going to reflect us over the x-axis. So use this guide on these problems, okay? All right, y'all, so that and left with the 2 being positive, up 4. So you're going to check that, and then they're going to make us graph it real quick. So I see the exponent of 2, so that's the x squared graph, which is the parabola, the U-shaped parabola. So click that anywhere on your graph. I'm going to start it in the middle. So we went left 2 units. So horizontal, go left to negative 2. Then we went up 4 units. So take that vertical and go to positive 4. All right, so after doing that, look, my graph went left and up. So now I save that and check my answer. All right, y'all, so this is the one. I showed y'all 2 examples, one with the numbers under the radical, one where the number was upside the radical. This number is inside the radical, so it's like it's in parentheses, okay? So when it's telling you you're starting with the square root of x, but what they want to know is when we subtract 7, are we going right, up, left, or down? Okay, so let me show y'all on this one what I would do on these radicals like this, okay? So on your radicals, you're going to have your y equals square root. So if it's like this, x plus or minus a, and then you got plus or minus b. If it's on the inside, it's still going to be left or right. If it's at the end like this, it's still going to be up or down. Okay? So up or down is automatically at the end. It's not inside these parentheses, radicals, okay? But if the number is inside the radicals, then you're going left if it's positive, right if it's negative, okay? So let's go back to this one. Was it inside, I think? Let's look. So that is inside the radical. So since it's negative, it's going to move it right. And then that would be 7 units. Okay? So inside the radicals are different than if it's outside that radical. All right, check the answer. So which one of these pictures went right? Well, A looks like it went left. B looks like it went up. C looks like it went right. And then D looks like it went down. So we went right 7. So we would highlight C. There you go. And check our answer, okay? All right. This is another radical. It's going to be the cube root. But this time, the plus 3 is not under the radical. So since that 3 is not under that radical and it's added at the end, am I going to go down, right, up, or left? And we're going to go perfect. We're going to go up. So y'all, what's that? C. Shift the graph 3 units up. Check that answer. All right, so which one went up? We got A, we got B, and we got C. It looks like B is the basic graph going right through the center. So did A go up or C go up? So what are y'all saying? A? Yeah, it looks like A went up, right? A, the graph usually starts in the middle, but this one went up. B would be the actual basic graph, and it looks like C looks like that and sort of went down. So since we went up, we would choose A on that one, okay? All right, so let's see what y'all do on this one. This one, we don't have to graph. We just got to tell what it's doing. So they got g of x equals negative x minus 2 squared plus 5. They're saying start with the graph of x squared. Then you're going to shift it blank units. So the first thing is that minus 2 inside the parentheses. Because that's going to do left or right is going to be what that number is inside the parentheses. So since that 2 is negative, since you're subtracting 2 inside the parentheses, now y'all watch out, you only got 4 choices. It's either right 5, right 2, left 2, or left 5. When you subtract 2 from the x inside the parentheses, subtracting 2 is going to move me right 2, okay? Then reflect it across the, and y'all, there's only one axis worth reflecting over, and that's the x-axis. You will not answer y-axis on none of these problems, okay? Because we haven't learned how to reflect over that one. Only the x. All right, and then shift it blank units. Up 5, down 2, down 5, or up 2. So y'all, what are we doing on that one? Up, down, or down 5, up 2? And that 5 is being added at the end. So that's going to go up 5. And y'all, then I would check my answer. So let me go through here and let y'all do some of these randomly. All right, y'all, number 3 here. H of x equals 1 over x minus 3. They're telling you you're starting with the 1 over x graph. But what's that negative 3 doing to that graph? Are you going to pick A, B, C, or D? Are you going 3 units down, 3 units right, 3 units up, or 3 units left? And remember, that number is being added at the end of your function. So Claire, Jesselyn, y'all are saying down. Perfect. You're going to go down on that one, okay? All right, so knowing that, let me pick number 5 and see what that one was. Okay, so we know since that's a square, we're going to start with x squared on this one. And then we're going to shift it blank 1 unit. So that 1 is being added inside those parentheses, y'all. So since it's being added inside the parentheses, am I going to go down, up, left, or right? Oh, Claire, perfect. You got me going left on that one. And then the plus 4 going up 4 units. Good job. Okay, so y'all got to get used to that. Inside parentheses, under radicals, left or right. Outside the parentheses, outside the radicals, up or down, okay? All righty, y'all. So let's see. Cube root of 2. I mean, cube root of x plus 2. Is that plus 2 added at the end going to move me A, B, C, or D? 2 units down, 2 units right, 2 units up, 2 units left. So would y'all go with A, B, C, or D? And that's going to go up. So let's see. C is up. Good job, y'all. And then remember that when you checked it, it had your pictures. So y'all, A, B, or C, which one of those went up? Perfect. Looks like C. Yep, C looks like it went up. B looks like your basic graph, and then looks like A went down, okay? All righty, y'all. So that's really oh, let me do this one and then we'll be done. How about that? So start with the graph. They're giving you g of x equals negative x minus 6 squared plus 7. So they're saying start with the graph of x squared. We're going to shift it blank units. So this is left and right. So to go left or right, you're looking inside those parentheses. So that's a x minus 6. So y'all, left 7, right 7, left 6, or right 6. What would y'all choose on that? So right 6, so let me go to right 6. All right, then you're going to reflect it across x-axis or y-axis. X, good job. And then you're going to shift it up 6, down 7, up 7, or down 6. So now we're looking at that, what, that plus 7 now? So up 7 on that one. Good job, y'all. And then be done with that, okay? All right, y'all. Any questions on those? Yeah, just get used to them. Really, to me, it's getting used to this picture right here. The negative in front, like we said, only did the x-axis. If it was inside the parentheses is left or right, pluses or minuses, okay? At the end of the function, a number at the end being added or subtracted, just a number dangling at the end is going to be your up or down. Now, inside the radical right here is the same thing as being inside parentheses, okay? And then you'll have that up or down number at the end. So let me see what my chat's saying. Okay, so this is what y'all want to write, okay. And yet, even this one, if you threw a negative in front of that negative in front of the radical, that would do the same thing as this and reflect it over the x-axis. Okay, so the negative in front, the radical right here is the same as the parentheses. And then when you add or subtract at the end, is the same as adding or subtracting at the end of those, okay? And then y'all remember to play with those, you're looking at these 7 basic graphs. These are in your um, week 2 folder, okay? When you click on the week 2 folder, open it, it'll have a picture of all these 7 graphs, okay? All righty, Jessica, you got this, what you needed? Okay.